Hello and welcome back. We are now dealing with surds. Now, this says, let's read through what this says. It says a surd is an irrational number expressed as a square root. Okay, what are irrational numbers? We did this right in the beginning that irrational numbers are numbers that cannot be expressed as fractions. Numbers cannot be expressed as fractions. Okay, so all roots that don't simplify, for example, I can show you on my calculator that there is going to be let's say root 2. If you do this, it gives you a decimal, but it doesn't convert back to a fraction. Okay, the root remains where it is, so therefore root 2 is an irrational number. Okay, root 4, for example, is not an irrational number. Why? Because it simplifies to 2, which can then be written as 2 over 1. Okay, so root of 9 is not a surd because it can be expressed as a rational number, that is 3. 3 is basically 3 over 1. Okay. Root of 6 over 6 whole 1 over 4 is also not a surd because it can be expressed as a rational number. You can get 5 over 2 out of root of 6 whole 1 over 4. So root of 2, root of 3, root and 5, root of 5 are surds because they are irrational numbers that cannot be expressed as fractions. This is something that we have already seen. I think my screen blacked out. I'll just fix that. Okay. Because they're irrational numbers, so that they cannot be written as a over b, where a and b are both integers. Okay. In the same way, 5 plus root 2, 5 minus root 2, 5 root 2, and root 2 of 5. Root 2 over 5 are also irrational numbers. Why? Because a root is there. A root makes everything irrational. So the entire number is irrational in this case. Yes, it has a real component. I can say 5 is a real part and so on. But that's not something that we need to worry about. Okay. Okay, the actual value of root 2 is 1.414, which cannot be written down exactly. There are no groups of digits that recur. Okay, so it's not a recurring decimal either. Okay, our job in this section is to simplify sets and how to convert them into and how to convert irrational denominators of fractions to rational denominators. We'll talk about that in a bit. The 3 rules given below will be used in this exercise. Okay. So the first thing that I need to know, or I need you to know, is that when you take a root of a square, the roots obviously cancel out, and you're left with a. If you put this root yourself, then there is a fair chance that a could be both plus and minus. We'll talk about that in a bit. The important one that I want you to know is that when you multiply a root with the same root, it becomes a. Now, there are two reasons behind it. One is that it combines to form something called a into a, which is a square. Okay, that's one way of looking at it. The other way of looking at it is that you know that when bases or same powers get added, so half plus half makes a total of a power 1. This is a very important rule for this chapter that you need to remember. Okay. The other rule that you need to remember is that the root can come up common and the numbers can get multiplied inside. So that's something that you should also be aware of. The first example that I have is not related to multiplying or dividing or anything for that matter. Okay, it's just about simplifying these sets forms. Okay, whenever you want to simplify a number that's inside a root, you start off with prime factorization. Now, I understand that some of you have learned prime factorization differently by making a tree of sorts. Okay, and that's also fine. I've always done prime factorization this way. So I'm going to continue with my prime factorization like that. 2 times 9 is 18. 2 times, no, 3 times 3 is 9. And 3 times 1. The root of 18 can basically be written as 2 into 3 into 3. Now remember that whenever you have a root, anything that's inside the root and forms a pair combines together and comes outside the root as just one single digit. Okay, so there's going to be a 3 outside. Why? Because there was a pair of 3's inside and a 2 is left over. Okay, that's how you simplify roots. Let's do it on another one. Okay, let's see root of 600. 2 times 300, 2 times 150, 2 times 75, 3 times 25, 5 times 5, 5 times 1. So let's see how many of these numbers are forming pairs. So I see that there's a pair of 2's and there's a pair of 5's. The pair of 2's and there's a pair of 5's. The other two numbers don't have pairs. What's going to happen is that 2 is going to come outside the root. There's going to be a 5 outside the root. They're going to get multiplied. Why? Because they were multiplied inside. Okay, so they're going to be multiplied outside, but they've combined together to form just one number. Okay, what am I left with inside? There's 2 and there's 3. So this becomes 10 root 6. Okay, let's talk about root of 448, and I'm going to do it here in the next example. Why? Because we've run out of space on this one. Mark a boundary so that we know we're doing example 23. Let's talk about root of 448. Sorry. So 2 times 224, 2 times 112, 2 times 56, 2 times 28, 2 times 14, 2 times 7, 7 times 1. The root of 448 can be written as 2 into 2 into 2, 3 twos, 6 twos, 6 twos, and a 7. This number forms a pair, another one forms a pair, and another one forms a pair. So there are a total of 6 twos. The pairs will combine together to form one, and there are going to be 3 twos outside now, and the 7 is left inside. That makes a total of 8 root 7. Okay, I hope that's clear to everybody. Let's talk about this then. Root of 8 over 10. Okay, can root of 8 be simplified? Yes, that's simple. 4 to 1. Okay, so that's 3 twos divided by 10. So these two combine together to form 1 and come outside. Times 5. Okay, I hope this idea of simplifying roots was clear to everybody. You should do some more practice and make sure that you know how to express something in the simplest form. I'll see you in the next video where I teach you addition, subtraction, multiplication, and so on. Thank you for watching.